Hi there. With this section 4.4 to 4.6, what I'm going to do is I'm going to go through your homework. Now your numbers will be a little bit different than mine, but at least you'll have an example of how to solve these. You know, if for instance, if you have trouble with number 3, you can look at how I solved number 3 or number 30 or whatever. So what we're going to be doing in section 4.4 is we're going to be solving equations. And there's a couple of ways you can do these. One is to keep the fractions and deal with the fractions, and there's nothing wrong with that. But another method that you're going to need to be familiar with is called clearing the fractions. So that's what I'm going to kind of spend some time on is how to get rid of the fractions before you even start to solve it. And it'll make it a little bit easier if you don't have the fractions. So on number 1, we have 1/2 plus t equals 4/5. So I'm just going to copy it over right here. Okay, there's nothing wrong with subtracting 1/2 from both sides. You know, you could subtract 1/2, you can get a common denominator and get your answer that way. But another method is, because it's an equation, you can multiply every term by something, and whatever that is can get rid of the 5 and the 2. Well, let me explain that. So that something is a number that both 2 and 5 would go into evenly. So you're really multiplying every term by the least common denominator between the 2 and the 5. So, and just kind of stay with me, it'll make sense once we go through the example. But I know that 2 and 5 both go into 10. So I can multiply every term by 10. And don't forget about this side over here. So the 1/2 times 10, the t times 10, and the 4/5 times 10. So I need to take 10 over 1 times 1/2. Then I need to take 10 over 1 times t. And then I need to take, I put it over 1, it's just easier when you're multiplying with fractions. So I need to take the 10 times every term. And you'll get faster at this. So when I take 10 times 1/2, 2 goes into here once, 2 goes into here 5 times, I reduce. This will always be a 1 down here if you've done it correctly. Then 5 times 1, that's all that's left, is 5. Plus, you go to this. 10 times t, nothing cancels. It's just 10t. 10 times this, the 5 goes into here once, 5 goes, I'm reducing the fraction, so we're going back a few sections. So once you reduce the fraction, 5 into here once, 5 goes into 10 twice, you multiply across, 2 times 4 is 8. And that's the equation you're going to solve. All right, so no fractions here. How do you solve this equation? Well, in order to solve this, you get rid of what's being added or subtracted first, and that would be the 5. So you subtract 5 from both sides. So you add its opposite. So then we have 10t equals 3. Now, to get the t by itself, or a 1 in front of the t, if it's 10 times t, you divide by 10. This step, the sign always matches what you're getting rid of. This first step, it's always the opposite. So t equals 3/10. Now that may not be as easy to put back in and check it, you know, to put it back into our original. Okay, you can put it back into the original, which is 1/2 plus t as a check. 1/2 plus 3/10. If you had a calculator, you could add those with your scientific calculator, and you would come up with 4/5. So, and it does, it works. You could get a common denominator of 10. It already has a common denominator of 10. Multiply by 5/5 to make that bottom denominator there a 10. So we come up with 10 and 5. So you have 8/10, which reduces down because 2 goes into both of them, 4/5. So it does work. All right. Another way you can check this on the calculator is this is 0.5. 1/2 is 0.5. 3/10 is 0.3. Take 1 divided by 2. 3 divided by 10. 4 divided by 5. 0.5 plus 0.3 is 0.8. Whoa, sorry, I couldn't see that. 0.5 plus 0.3 is 0.8. So you can change them to decimals to check it as well. So it does check. You can also put in the 3/10 back up into this one right here, the one that we created when we eliminated the fractions. So you'd have 5 plus 10 times 3/10. So that gives you 5. When you multiply these, the 10s cancel. And so you end up with a true statement. Okay, either way. All right, that's what we're going to work on a lot, is clearing fractions. Let's look at number 2. All right, so number 2. Now maybe you can do these as we go through them. We have x plus 1/12 equals a negative 5/6. What I'm going to do is I'm going to clear the fractions. You guys, you could just subtract 1/12 from both sides, get a common denominator, and combine them. All right, and you'll get the answer. But I want to practice clearing fractions. So what I'm going to do is a number that both 12 and 6 would go into would be 12. The least common denominator between 12 and 6 is 12. 12 goes into 12, 6 goes into 12. So I'm going to multiply each of these terms times 12. And I'm going to write that down. 12 times x, that's the first one. 12 over 1, I'm going to go ahead and put it over 1 for these fraction ones. So 12 times 1/12. 12 over 1 times a negative 5/6. All right, so we're going to do these 3 multiplications. 12x. Here, 12 goes into here once, 12 goes into here once. So we end up with 1 times 1, which is 1. Here, 6 goes into here once, 6 goes into here twice. 2 times a negative 5 is a negative 10. Okay. So again, I took 12 times each of these. Okay, I reduced before I multiplied here. And then once you multiply your fractions, you'll end up with whole numbers every time. Well, not whole numbers necessarily, sorry. That's not a whole number, that's an integer. You'll end up with integers every time. So now we solve it. You get rid of what's being added first by adding the opposite. Divide by 12. So x equals a negative 11/12. And you could put that back in, especially into the original, because they're both, you have x plus 1/12. Some of these I may stop checking just because I want to get through all of these here without too much time. But here, put a negative 11/12 in. Okay, here they have a common denominator. So if I have a negative 11/12 plus a positive 1/12, I'm going to get a negative 10/12. Okay. which reduces down. 2 goes into both of those, divide them both by 2, and I end up with a negative 5, 6. So it does equal. They are equal. All right. Okay. Let's look at number 3. Hope I have enough paper here. I think I do. All right. Number 3, these are no fractions. So this is just a review of getting the x by itself. I'll just kind of walk you through this one because we have quite a few to practice. So here, without, you don't have the clear fractions, here you would add 2 to both sides and then divide by 7. Okay, so you would add the opposite and then divide by 7 to solve it. All righty. But so that's how you would do number 3. Add 2 and then divide by 7. So it looks like your answer is going to be 5 on that example. Oh, and another one, number 4. You don't have to clear fractions. You just need to get the x by itself. By the way, these are called two-step equations because it takes 2 steps to solve them. You're adding the opposite and then you're dividing. Let's go ahead and do number 4. All right, so we've got 7x plus 8 equals 14. Your 2 steps, we always add the opposite first, minus 8 to both sides of our equation. I've kind of stopped drawing that line through there. Whatever you do to one side of the line, you do to the other. That leaves us with 7x equals 6. Okay, positive 6, because you have more positives than you do negatives. Now I'll divide by 7. Here, the signs always match on this section here. It's positive 7, positive 7. It'd been a negative 7, I'd had a negative 7. Negative, oh, positive 6/7. And then you could put that back in, and it looks like the 7s will cancel, so it does work. When you put 6/7 back here, the 7s will cancel. One's in the numerator and the other's in the denominator. So 6 plus 8 is 14. Good idea to check. All right. Let's do number 5. We're going to eliminate the fraction. Well, we'll do both ways. All right. We're going to not eliminate the fraction, and then just to kind of give you guys the idea that you do have choices here. So we've got 2/3 y. Okay, let's not eliminate the fraction. I've just got this one fraction in front of the variable. And the more of these you do, the more you recognize, I wonder what would be an easier method. But here, you could multiply everything by 3, but let's go ahead and add 8 to both sides. We're going to leave that fraction alone, just to kind of review that it can be done. 11 plus 8 is 19. Make sure I copied it down right. Seems like that's what I did. All right, so to get rid of the 2/3, okay, remember when you have a fraction in front, you multiply by the reciprocal to solve it. Because what you're doing is, this is 2/3 times y. When you could divide by 2/3, dividing by a fraction is the same as multiplying by the reciprocal. So 19 divided by 2/3, to get rid of that 2/3, you divide by 2/3, is the copy dot flip. You multiply by the reciprocal. So you can skip to this step right away. Multiply by 3/2. Okay. So we end up with 19 times 3/2. So I did not eliminate the fraction here or clear the fraction. But when we multiply, we put our whole numbers over 1 and try to reduce. Well, nothing goes into 19 and 3 and 2. So we're just going to multiply across. And let's see, 19 times 3 is 57. 1 times 2 is 2. And then my math lab should accept that Yeah, without making it a mixed number. We're not making them a mixed number, but we will in the next section. So that would be your answer. Okay. Another way you could have done this is to clear the fraction. So here we would have had 2/3 y minus 8. Second here, sorry, sorry, I had to stop the recording for just a second. So we've got 2/3 y minus 8 equals 11. All right, so now in order to solve this, well, sorry, we're going to go ahead and we're going to eliminate the fraction first. So here we're going to multiply by 3 every term. Okay, so that gives us 3 over 1 times 2/3 y, 3 over 1 times 8. You don't have to put that. Since that's just a whole number, you probably didn't need that one, but it's there, so I'm going to leave it. And then 3 times 11. So I'm just taking 3 times every term. Here they cancel because 3 goes into here once, 3 goes into here once. So we're going to solve 2y. 1 times 2 is 2y. 24, 3 times 8, 3 times 11. All right. So that's my new equation. And the value of y has not changed, but the looks of the equation has changed. These y values represent the same number. I've just kind of changed the looks of my equation. So I'm going to add 24 to both sides. So this is a two-step. Get rid of what's being added or subtracted first. So we have adding the opposite, negative 24, positive 24. Add those, divide by 2. Y equals 57 over 2. Now, last step, you divide, get rid of that 2y to get rid of the 2. So as you can see, it's the same. All right. So, you can add 8 and then deal with the fraction in front by multiplying by the reciprocal, both sides. Or you can eliminate the fractions and deal with it there. All right, let's do a few more of these. Turn this page over. Let's look at number 6. Let's eliminate the fractions, especially because there's so many of them. All right. I have no idea what I have on these. All right, so let's go ahead and look at 7/2. Okay. So we've got 7/2 x minus 1/4 equals 1/2. I don't want to deal with fractions. I want to get rid of them. So I need to, what would 2, 4, and 2 all go into? What's the least common denominator here? Well, it would be 4. All right, 2 goes into 4, 4 goes into 4, 2 goes into 4. So I'm going to multiply every term by 4. And you can do that. This is an equal. You can only do this when we have equations. But if I just asked you to add 2 fractions, you're going to have to get a common denominator and add them together. So try not to get them mixed up. This is when you're dealing with, when you have an equation and you're solving for a variable. Okay, so we're going to take 4 times our first fraction. I'll put 4 over 1. And then 4 times our next fraction. 4 times our next fraction. All right, so let's do these 3. We have 3 multiplications to do, not too bad. They'll always reduce. 2 goes into here once, 2 goes into here twice. So I reduced it. Now you multiply across 14x. 4 goes into here once, 4 goes into here once. I multiply across and you get 1. 1 times 1 is 1. Still a minus there. So then reducing this, 2 goes into here once, 2 goes into here twice. Multiply across, you get 2. So rather than solving my original with all these fractions, you can solve this one. You've cleared the fractions and get the same answer. And so that's what we'll do. We'll solve this one, not dealing with these fractions. And again, to make this one look like this one, I multiplied each of these three by what these denominators would go into, which would be a 4. All right, let's finish it up. Add 1. So 14x equals 3. I have to move it up just a bit. Now you divide by 14. So x equals 3/14. Now you could put this back into the original. You could take 7/2 times 3/14. All right. And then subtract 4, and you're going to get 1/2. Okay. All right. So just, and again, when you put 3/14 into here, the 14 and the 7 reduce, and so it's really not that bad. Okay. All right. Now let's do another one. Number 7. I'm going to go ahead and practice eliminating the fraction. 5 minus 6/7 b. Now this one is very similar to number 5. You know, you could get rid of the 5, move it over here, move the 5 over, add a -5, and then multiply by the reciprocal of this, both sides. And it's not wrong to do that. I just want to make sure you know how to clear fractions. So that's why I'm kind of concentrating on that idea. So I'm going to multiply every term by 7. And the reason 7 is the only denominator is a 7. And so 7 goes into 7. So I'm going to multiply every term by 7. So I'm going to take 7 times 5. Have that minus there. 7/1 times 6/7b. So this times the second term. And then I'll take 7 times the last one. So I took 7 times 5, 7 times 6/7, and I did put the 7/1 just to make the multiplying of the fraction and reducing easier. And then 7 times 6. Okay. So we have 7 times 5. Here, the 7 cancels. Now this bottom number will always cancel. It should, or something's wrong. So we get 7 goes into here once, 7 into here once. So we've reduced it. Now we multiply 1 times 6. 1 times 6 is 6b. You don't have to put it over 1. 42. 7 times 6 is 42. So now we solve it. We subtract 35 from both sides, and that might be kind of a hard thing to notice, is that you need to get rid of the 35, not the -6. Okay, the -6, it's a -6 times the b. So even though it's in front, you still has to be eliminated first. Okay, you get rid of what's being, this is kind of being added or subtracted to the b. This, it's gone. So we have a -6b, and that is 7 for an answer there. So now to get rid of the -6, and you know, that's next to the b, it's a -6 times b. I'm going to divide by a -6. So notice that the sign matches here. You know, here it's always the opposite, but here in this step, it always matches. And the reason is a negative over a negative is a +1, which is what we want, a +1. And a negative over a negative is a positive because you have 2 negatives and 2 is even. So when you have an even number of negatives, it's going to be a positive. So we have, a -7, 6 can't be reduced, but I think I might put the negative up on the top with the 7. It doesn't matter where it happens. Okay. Now, if you were to multiply this, or excuse me, if you were to substitute this back into here, when you take a -6/7 times a -7/6, the 7's cancel, the 6 cancel, and you end up with a +1. When you substitute that back in, it's a +1. So 5 + 1 is 6. It's pretty awesome. All right, so get another one. That was number 7. Yeah. Turn this over. And let's look at number 8. So we have plenty of these to practice. Okay, what I would like to get rid of is the 13ths. So I'm going to multiply every term by 13 because 13 goes into 13 and 13 goes into 13. So I'm going to take 13 times a -1 plus 4/13t. Oops. I'm just going to put it around the whole thing. Equals a -12/13. So I'm going to be multiplying by 13. I hope that idea, if you're having trouble coming up with what we're multiplying by, please contact me and we can kind of go through it and give you some ideas or some strategies on how to come up with this number here. So we're going to take 13 times a -1, 13/1 times 4/13t. Okay, there's 13 times that term, equals 13 times this, 13/1 times a -12/13. Okay. So now I'm going to multiply, I'm going to reduce, and the 13ths in the denominator should disappear, and then it's a two-step equation and you solve it. So here, the first multiplication is going to be a -13. Okay. So then the next one here, I'll reduce. 1 times 4 is 4t. They reduce. 1 times a -12 is a -12. So now we're ready to, I need another sheet of paper. I'm running out of paper. So now we're ready to do our two-step equation. It's 4 times t, so we'll get rid of this plus a -13 first. So you get rid of this by adding the opposite. Oh, but not 12. The opposite is a +13. You did it to one side here, you have to do it to the other side of the equal sign. 4t equals 1. Divide by 4. To get rid of the 4, notice I don't change the sign here. It matches. So you get a +1t equals 1/4. Now you could put this back either here. 4 times 1/4 is 1. When you take a 4 times a 1/4, the 4's cancel. -13 plus 1 is a -12. You could put it back here, the 1/4, which the 4's would also cancel, and you're left with 1/13. So a -1, which is a -13/13, plus 1/13 is a -12/13. Either way, the check is going to work. All right. I kind of like to do that last check because it's a good idea of how to change this. So I'm going to take a -1. This is the check to see. I'm going to put my answer back into the original to see if I come up with the left equals the right, a true statement. -1/4 back up into the original without the 13. So I've got a -1 plus 4/13 times 1/4, because that's what I got for the t, is 1/4. I multiply -1 plus this cancels. 1 times 1 is 1. 13 times 1 is 13. Well, a -1 is the same thing as a -13/13. And I wanted to match that. A -1, you know, if that had been a 14, this would have been a -14/14. If that would have been a 15, a -15/15, it's negative because of that. So I matched the denominator is what I did. If that had been a 20, I would have had a -20/20. Right? This, if I reduce this, I come back. -13/13 plus 1/13. When I add these numerators, if I have a -13 and I add a +1, I have a -12/13, which is what I wanted. So it works. This is the idea I wanted to look at. All right, so perfect. Great. Let's do another one. I'm hoping you're catching on. Number 9. Okay, on number 9, we have a -15. I want to get rid of that 7th. Now you could add 5 to both sides, fine, and then multiply by 7/5, the reciprocal, and that would leave the a by itself. I'm going to go ahead and eliminate the fraction. I'm going to multiply by 7, because 7 goes into 7 and it's our only denominator. If there had been a 2 here under the 5, I'd have done 14, because 7 and 2 go into 14. But anyways, 7 times a -5 is what? The -105? Yeah. Now equals, oh, I guess I didn't rewrite it. And I have been, so I'll just keep doing that. This times this is 7 times a -15 equals, we have an equal next, 7/1 times 5/7a. Okay, that's that fraction times that, minus 7. 7/1 or just 7. We'll just do 7 since that's not a fraction. Okay, 7 times this term, 7 times this, and 7 times this. Every one of them has to be multiplied by 7. So now we have our -105 equals, the 7's cancel, and we end up with 5a minus 35. Okay. So again, we just eliminated the 7, and now we have a two-step equation. We're going to add 35 to both sides. This is a great practice in solving two-step equations. So we have 5a equaling, here you're going to end up with, it looks like -70. Yep, -70. And then you're going to divide by 5. So we'll divide by 5 both sides. There's one thing I wanted to, right here, okay, this is over here on the right-hand side. I wanted you to know that these, you can put the 5a on the left. Okay, these two mean the same thing. You can swap sides. And this is an important thing to remember. You can just flip those over. Sometimes people like to see the variable on the left and then solve it, divide by 5. Not that you have to, but you can. So realize that these two mean the same thing. All right, so, but here we'll divide by 5. I know that 5 goes into it evenly because it ends in 0. So we have a equals, let's see, 5 goes into 70, goes once, 14 times. So here, I just divided it by hand here. So that gives you 20. And you have the 1a. Or a equals, again, you can swap it, negative 14. And you could put that back into the original, take 5/7 times a negative 14, subtract 5, and you should get a negative 15 for number 9. Okay, perfect. So there's our answer. And we just eliminated the fractions. Let's try another one. Let's see, let's pick a harder one. Let's skip down to, like on this one, number 10, you could multiply every term by 6. Okay. On number 11, you could multiply each of these by 5 and come up with the right answer. Let's look at 12 though. Let's skip down to 12. I don't want this video to run too long. So on this one, we're going to have 1/3 x minus 1/6 equals 1/3. So I need to get rid of the 3's and the 6's and the 6. What do 3 and 6, what would they go into? Well, they would all go into a 6. So 6 divided by 3, you get 2. 6 divided by 6 is 1. 6 divided by 3 is 2. So I'm going to multiply by 6. All of those go into there, okay, with none left over. So I'm going to take 6/1 times 1/3 x, the first one, minus 6/1 times 1/6 equals 6/1 times 1/3. It's a good review of multiplying fractions. Reduce them, multiply across. 3 goes into here once, 3 goes into here twice. So you end up with 2 times 1 is 2x. Don't forget your x. 1. 1 times 1 is 1. You still have that subtraction. So you get 1. And equals, 3 goes into there once, twice. 2 times 1 is 2. So now you do your 2 steps. You get rid of this first by adding the opposite, plus 1, to both sides of our line here, both sides of the equal sign. This is always adding the opposite. This will always be opposite here. So you come up with, at 0, if you have a -1 and a +1, they cancel each other out. 2 plus 1 is 3. Now here you don't switch the sign and leave it as 3/2. They'll want 3/2. And there you're done. Okay, great. Now you could put this back in right here and take 1/3 times 3/2, and you're going to get, when you then you subtract the negative, or you subtract 1/6, you'll get 1/3 when you put that back in. Okay, all right. Oh, let's do another one. Let's do 13 and 14, and we're almost done with these. Maybe the other ones won't take quite as long, but I want to make sure you know, or have good examples for each. Straighten it out a little bit. Move this over. All right, we need to get rid of the 8 and the 4 on number 13. And again, your numbers will probably be a little different. So I need to get rid of 8 and 4. So 8 and 4 will both go into 8. So that's what I'm going to multiply every term by, is what these two would go into. So I'm going to take 8 times all of those. So 8 times this, 8 times this, and 8 times this. So -3 times 8. I'll multiply those. Here I'll take 8/1 times 3/8t. Then I have my subtract sign. 8 over 1 times 1 over 4. And then you reduce and multiply, and you have a whole new equation that's easier to solve, but will have the same answer. This is a negative 24. Here, 1, 1. So you end up with 3t. 1, 2. 2 times 1 is 2. So now you solve this one rather than the original with all those fractions. To solve this one, if you want to, you can move this part to the left. You could swap them just so that, you know, your variable's on the left, or you can just go ahead and solve it here, add 2. So we'll get rid of what's being added or subtracted first, add its opposite, positive 2. So that's a negative 22, because if you have 24 negatives and you add 2 positives, these 2 will cancel out 2 of those. So now you've only got 22 negatives left. Divide by 3. So t equals, and again, this is not the opposite right here, it's the same sign. Can't be reduced. There you go. So t equals a negative 22/3. Doesn't matter where you put that negative, as long as it's there. You could put it back into the original. 3/8 times a negative 22/3, even on your calculator, and subtract 1/4, you're going to get a negative 3. So you can check that on your calculator, that's fine. That's good. No other space there. Tell you what, let's do one more. That was number 14. Was that number 14? 13. So do I want to do 14 or here? Tell you what, let's do 15. Okay, this is number 15. Even though you can't see the 15, this is 15. Okay. All right, so we need to multiply by something that 6, 9, and 3 would all go into. Well, let's see, 18, because 9 times 2 is 18, and 6 times 3 is 18, and 3 times 6 is 18. So these will all go into 18, and it does help to know the multiplication tables as best as you can. So again, 18 is what we'll multiply by. 1/6. So I'm going to multiply by 18 because they'll all go into 18. So we have 18 over 1 times a negative 1/6. 18 over 1 times a negative 5/9 minus 18 over 1 times 1/3 x. Okay, I just put that subtraction there. And then I had the 18 times the 1/3. So I'm taking 18 over 1 times each of those 3 separately. Here, 1, 3. You'll always end up with a 1 down here. 3 times a negative 1 is a negative 3. You only have one negative. 1 is an odd number, so it stays negative. You have an odd number of negatives. It'll stay negative. Okay, 9 goes into here twice. Excuse me. Yeah, got ahead of myself. 9 goes into there once. 9 goes into there twice. And 2 times a negative 5 is a negative 10. Subtraction. 3 goes into here once. 3 goes into here 6. 6 times 1 is 6x. So now we have this to solve. Okay, so it kind of looks a little confusing. Just concentrate on each multiplication separate, and I think you'll be fine. To solve this, I need to get rid of the negative 10, is what you need to get rid of. This is a multiplication to the x right here, is times. So I need to get rid of this by adding the opposite, positive 10, to both sides of the equal sign. That's gone. That's a 7. That subtraction is plus a negative, so you have a negative 6. Okay, now to get rid of the negative 6, you divide by a negative 6. So this last step, when you're dividing or multiplying, the sign that those will always match. So, because you want a positive 1x, and there you have your answer. You can put it back into the original. I would do this I would check it on a calculator. Negative 5/9 subtract 1/3 times a negative 7/6, which is your answer here. And you should get a negative 1/6, okay, for a check. All righty, so that pretty much does the eliminating of fractions. So I'm hoping that you understand. So now we're going to look at 7.5 here. Kind of almost a totally different idea. We want to convert 7 and 5/6. Notice 7 and 5/6 is how we read that. So remember, and means a decimal. So eventually we'll be making these decimals. So this fraction could be written as a decimal. So we have 7 and 5/6. We want to convert it to a fraction. This is considered a mixed number. So to convert it, when MyMathLab asks you for a fraction, it doesn't want 7 and 5/6. It would rather have an improper fraction. Normally we used to call these improper fractions. Now they just call them fractions. So what you do is you take 7 times 6 and add the 5. So I'm going to make this 7 a little bit larger. Move it up. So you multiply those, so you times them, and you get the answer, and then you add the 5. So that's a plus. So you always multiply, always add. Always multiply, always add. So 42 plus 5 is 47, and it always goes under the same denominator. So this mixed number and this fraction represent the same amount. So that's what we're going to be doing here for the next few problems. Let's do another one. It's a negative. All right, so what do you do with that negative? Well, you ignore it until you write your answer and you put a negative in. So we'll have 11 and 1/4. Okay, so we're going to ignore the negative right now till we're done. 11 times 4 is 44. And then you add the 1. So negative 44 plus 1 is 45. Over 4, you always put that same denominator here, but now it's negative. Just make your answer a negative. Okay, let's try another one. Good, we have lots of practice here. This should be easy for you by the time you're done. Not really sure why I put that 3 down so low. Okay, you multiply these two together. 3 times 10 is 30, and then you add in the 1. So you get 31, and you always put it over the denominator. It was positive, it stays positive. All righty. Let's try another one. Here, I have that negative, so I know my answer will be negative. But to do the problem, we'll ignore that. 5. So we're going to convert it to a mixed numeral. Ooh. Yeah. Okay. So we're going to take 5 times 100. So we're multiplying these. And you get 500. And then you add in the 53. So you always multiply and then you add. So we'll have 553. You take 500 and add this, always over the fraction, that same denominator. Now our original was negative, so don't forget to put in the negative when you're done. All right. Another one that is not here, just in case we want to practice. Let's say I have 2 4/5, and I wanted to write this as a fraction. 2 times 5 is 10, and then you take and you add in the 4. Always over 5. All right, and if it was negative, if it happened to have been negative, you'll make it negative, but that was kind of an extra practice. So I'm hoping that that doesn't give you trouble adding or switching over to a mixed number to a fraction. Just a second, please, Belle. All right. Let's look at number 20. 20, they want you to go the other direction. You're given what we used to call an improper, now they just call it a fraction, to a mixed number. So we're going to take 11/6 and change it. So what we're going to do is we're going to use division. Okay, 6 goes into 11 once without going over. Twice would be 12, that would be too many. So 1 times 6 is 6. So your answer is 1 5/6. So you got the 1, that goes here. And then you put your remainder over this divisor here. So 5/6. And there's your answer. You can check it. If you multiply this and make it just what we were doing earlier, if you were to take 1 times 6, you get 6, plus 5 is 11 over the 6. So you can multiply and add the 5 in to go back to here. Change the mixed number to improper. You need to go from a mixed to an improper fraction and a fraction to a mixed numeral. So let's practice more of those. Number 21. So we've got 23/10. So we're going to change it. So we're going to use division. The top number always goes in the box, always. So how many times can 10 go into 23? Twice without going over. 2 times 10 is 20. Subtract them. So your answer is 2 3/10. And that would be your answer. 2 3/10. Multiply it out, change this back to an improper. 2 times 10 is 20, plus 3 is 23/10. You come back. You can always check it. All right, hopefully we have some more of these. We do. Number 22. Convert this to a mixed numeral. This is a fraction to a mixed numeral. 7 into 383. 7 doesn't go into 3, but it will into 38. It'll go 5 times without going over. So that leaves you with 35. 7 times 5 is 35. Subtract them, 3, bring down the 3. Let's see, 7 into 33. It doesn't go 5 times, that's too many, but it should go 4 times. 4 times 7 is 28. The remainder is 5 when you subtract those. 33 minus 28 is 5. So your answer is 54 and 5/7. 54 and 5/7. So you put the remainder over that divisor. 5 over 7 always. All right, so that's how you go from a fraction notation to a mixed numeral. Make sure you know how to go from a mixed numeral back to fraction. Multiply, add, and it's always over the 7. Okay, it'll always be over the 7. Okay. Number 23, they just kind of set it up for you. Here, you know, it's the division. It could have been written 4992. All right, write that as a mixed numeral. So we'll go ahead and do that. Shouldn't be too bad. We'll see. Okay, 7 goes into 49. Oh, wow, it's going to go even. 7 times 7 is 49. Which gives you 0. Bring down the 9. 7 into 9 goes once. 1 times 7 is 7. Bring down the 2. 7 goes into 22 just 3 times. 3 times 7 is 21 with 1 remainder. So 713 and 1/7. And there's your answer. 713 and 1/7 for a mixed numeral. Now, when you're doing MyMathLab, this template should show up. There should be a template that looks like this that you can fill in and push at the bottom and fill it in. All righty, so that will help. Okay, now here on 24, let's kind of talk about this. The table to the right shows the number of, one moment please, I'm going to straighten this out. Hi there. Well, here we have a story problem, and what we have is a table, and to the right shows the number of children who receive services from a nonprofit organization each year, as well as other related information. They want to know what is the average. Well, we know when we find average, we'll usually be adding up and dividing by how many we have. What is the average number of volunteer tutor hours for the school years 2007 to 2008 through 2012 to 2013? So again, they wanted the average number of volunteer tutor hours. All right, so first off, the average number of volunteer tutor hours. So you're going to be looking at this column right here, which is the number of volunteer tutor hours. So we won't be looking here or here. Now, you also have to make sure you read very carefully, because some of you may just start to add up all of these and then divide by how many there are, and you'll miss it. Because what they want is 2007 to 2013. So they're not interested in any of these. So again, make sure that you read these carefully when you're doing these problems. And then you'll just, you'll add these up and divide by how many, and you'll get hours when you do that. So I'll let you finish that. I just wanted to talk about a few things and make sure that you read it carefully here. So you'll just be adding up these and dividing. Once you do that, you press enter on a calculator, and you would divide by 1, 2, 3, 4, 5, 6, 7. All right, okay. That's how you do that one story problem. Now we're going to look at 25. And rather than adding fractions together, we're going to be adding these mixed numerals together. Well, it's just like the fractions here. You'll have to have these fractional parts have to have the same denominator, which they do. So when they have the same denominator, you can add the numerators together. So I'm just going to go ahead and cover this up, and we'll work with this top one on the right-hand side. They're the same. Because these are the same, you can add the numerators together. So I'm going to copy it over. I want it just a little bit larger. 6, 7, 18. All right. Because these are the same, I can add the numerators. Well, when I take 17 plus 7, I'm going to get 24. 24/18. So you add the fraction parts first. And these fraction parts have to have the same denominator, and we'll do some where they don't. We'll get a common denominator. It's not bad. Once you have a common denominator, you can add the numerators together. 17 and 7 give you 24/18. And then we're going to go ahead and add our whole number parts. 3 plus 6 is 9. Well, unfortunately, that you're not complete right here. This is not finished. First off, we need to concentrate. This fraction can be reduced. And it can be reduced because 6 goes into both of those. Now, if you didn't know that 6 goes into both of those, you should have known that 2 goes into both of those. So you divide by 2, and that answer, you're going to realize that, oh, 3 goes into both of those. So you can divide by 3, or divide by 2, then divide by 3, or divide by 6. 9 hasn't changed yet. 24 divided by 6 is 4. 18 divided by 6 is 3. So we reduce that fraction. The only problem is within this mixed numeral, I have an improper fraction, which you cannot have. So again, I added the numerators because they had a common denominator. I reduced, okay? But now this right here, I need to make into a mixed number. So I'm going to take 3 into 4. I'm going to do that right over here, I decided. Okay, 3 goes into 4 once. 1 times 3 is 3. So I have 1 and 1/3. 4/3 is 1 and 1/3. So then you'll add these two together. 10 and 1/3 is your answer. So I added the numerators here, reduced this fraction. Because this was improper, I changed it to a mixed number, 3 into 4. I get 1 and 1/3. So it goes once with 1 left over, 1 over the divisor. And then I took that 1 and 1/3 and I added the 9 and the 1. 10 and 1/3 is your simplified answer. All right, just take your time. I don't think any of the steps are too bad, but let's look at another one. Now this one will even have one more step because they don't have a common denominator. So let's look at your number 26. How would you do number 26? All right, so we've got 9 plus the 8, which we'll do later. Let's deal with those fractions first. We're going to ignore the 9 and the 8. So here, the common denominator I'm going to get is 10. All right, so I'm gonna find the common denominator off at the side rather than underneath. We normally only use this method for mixed numbers, numerals. When you get into algebra, it'll be, you know, where they'll be along in a row rather than a column. But I'm going to put, okay, 10 goes into 10 and 5 goes into 10. So that's my least common denominator. I'm going to change 3/5 to a denominator of 10, and 7/10 is going to remain a denominator of 10 because both 5 and 10 go into 10. 10 goes into here once, so 7 times 1 is 7. So multiply by 1, multiply by 1. Multiply by 2, multiply by 2. So you get 6. So I'm timesing by 2. I'll put a little 2 in there. Okay. Multiply by 2, multiply by 2. So 2 over 2. Now they have a common denominator. So now it's just like the one we did earlier. We can ignore this. We're done with that column. So we have 9 6/10 plus 8 7/10. They now have a common denominator. So hopefully you understood that last step of getting a common denominator. When I add these together, the numerators, I get 13/10. Looks like I have another mixed number coming up here. You know, if that had been a 3/10, then you add the whole numbers and you're done. Okay. So, you know, because this would not be a mixed number, but it looks like it will be. 9 and 8 is 17. Okay. If you stopped here, you would lose points. Actually, my math lab would count it wrong. So see if you can reduce it, but you cannot. Nothing goes into 13 and 10, but this can be written as a mixed number. All right, 10 goes into 13 once. 1 3/10. 1 3/10. They're the same. So I'm going to take and add the 17 and the 1 together. And sometimes people forget to add it. So make sure you come back and add it in. They'll do this and think that's the answer, but don't forget about the 17. There's your answer, 18 3/10. Awesome. All right, so we get to practice another one. This next one is subtraction. Is pretty much done the same way as the addition. So if for some reason you're still not confident with the adding, you can always do a similar question because you always have that option. It won't change the grade or anything. It just allows you to practice. So you can always do a similar question to practice an idea if you need that practice. All right, so here what we're going to do is we're going to subtract, but we still have to have a common denominator. I'm going to copy this over. I want more room. It's a weird too. You know, the key here, and they set it up for you, right, is that this top number needs to be larger than this number. 9 is bigger than 2. So always make sure that the larger one's on top here. So, all right. Okay. We have to have a common denominator. So we're going to get a common denominator, and it looks like 2 and 5 will both go into 10. All righty. So to go from here to here, you'll multiply by a 2. So that means you're going to multiply by 2. 2 times 2 is 4. So I have 4/10 rather than 2/5. They mean the same amount. Here, to go from 2 to 10, I times it by 5. Times it by 5. 1 times 5 is 5. 5/10 is 1/2. I'll just write them down. Okay. Now I'm going to subtract them. Now that they have a common denominator, so to add or subtract, you have to have common denominators. And it's just, a matter of finding your least common denominator. That is pretty simple. I mean, the 2 and the 5 aren't too hard. The numbers aren't big. Now, rather than taking and adding these together and getting 9/10 and being done, I have to subtract them. So I'm going to take 5 minus 4 and get 1. 9 minus 2 is 7. Okay, are you done? Do you need to do anything with the 1/10? Well, you can't make it a mixed number, okay, because 1 is smaller. The only time you have to do the mixed number idea, what did I do with those? Are those on the other side? Just a second. Okay. The only time you have to do the mixed number, the only time you have to do this is when this number is larger. It's called an improper. When this is larger, then you have to do this. 1 is not larger than 10. And it can't be reduced and you're done. So you get a common denominator and subtract the numerators rather than add. And then subtract these whole numbers. So 7 and 1/10. Let's do another one. Okay. I have 9 and 1/9, 6 and 7/9. And again, check. Here, the 9 is larger than the 6, so I've got that fraction on top. You don't look at these numbers. You look at these to see which one is going to be the higher one here, written on top, and this one underneath. You look at the 9 and the 6. That's good. Oh, they have a common denominator. That's awesome. The problem is you cannot take 1 minus 7. So we're going to have to borrow. So this is the same idea as if you had, let's say, 153 and you were subtracting 15. Okay, you can't take 3 minus 5, so you borrow and you add to this one. So you get 13. That's what we're going to do. Here, this is actually in the 10 spot, so you're borrowing 10. So 10 and 3 is 13. Okay, so you're borrowing from the 10 spot. We're going to be borrowing from the 1 spot, but it's still the same idea. We need to borrow from the 9. Okay, so here we have 9 and 1/9 minus 6 and 7/9. So what we're going to do is we're going to borrow. We cannot take 1 minus 7. So we're going to borrow from the 9. It's going to be an 8. And we're going to borrow a 1. So we're going to add 1 to this. Well, rather than write it as a 1, I'm going to write it as 9/9. I'm going to add the 1 to here. If this had been a 7, I would have added 7/7. If this had been an 8, I would have added 8/8. All right. So this represents the 1 that I borrowed. So I have an 8. 1/9 plus 9/9 is 10/9. Okay. And again, this always matches this denominator. Minus 6 and 7. Now you can subtract after you borrowed. 3/9. 8 minus 6 is 2. This can be reduced, all right, because 3 goes into both of those. So we have the 2. 3 divided by 3 is 1. 9 divided by 3 is 3. So there's your answer. 2 and 1/3 is not a mixed number. Okay, 1 is smaller than 3. You're done. Okay, let's try another one. Maybe we can practice this borrowing idea. I don't think it's the next one is one that I want. So I'm going to make one up just to practice that idea so you understand it. Let's do another borrowing just in case. Okay, let's say we have 7 and 3/5. I'm going to draw that a little bit better. 7 3/5 minus 2 4/5. Okay, if I were to subtract these, they have the same denominator, which is nice. We don't have to mess with that. The 7 is larger, so it's here on the top, okay, which is good. It's larger than 2. So here we need to borrow because you can't take 3 minus 4. So we're going to borrow from the 7. It becomes a 6. That 1 we're going to add to our fraction. So because it's fifths, I'm going to add my 1 as 5/5. Always match your denominator. So we end up with 6. There's our 6. This is 8/5. Okay. And this is minus 2 4/5. So now we can subtract them. 8 minus 4 is 4. 6 minus 2 is 4. This cannot be reduced. Something doesn't go into 4 and 5, and it's not improper, so you have to make it a mixed number. You're done. All right, so that was just kind of an added one in case that idea was giving you trouble. So, you borrow it and just match this denominator. 5/5 is that was a 7, 7/7. All right, it just makes it easier to add. They have the common denominator, you add the numerator. Perfect. All right, we're going to look at number 29. So we're getting down towards the end. So looking at 29. Ooh. Oh, it's kind of crooked there. Okay, we've got 35 and we're subtracting 9 2/7. Oh boy. Again, the 35 is larger, so it's on the top there, which is what we want. The only problem is we have nothing and we're subtracting 2/7. So again, we're going to borrow. So we're going to borrow, make this 34. We're going to borrow 1. We're going to borrow 1. And we're going to put that here. Well, how do we want to represent this 1? Okay, we're going to move a 1 over here. Well, I want the denominator to match. So I'm going to write that as 7/7. So we took 1 and we added it here. 7/7 is the number 1. If that had been an 8 instead of a 7, I would have added 8/8. Or if that would have been a 9, 9, 9. So make it easy on yourself. Make it 1 with a common denominator. So I borrowed 1 and brought it over. Okay. So now, because there's nothing, I didn't have to add it. I didn't have to add this 1 to anything. There wasn't anything there. So now you can subtract. 7 minus 2 is 5/7. Okay. 34 minus 9 is 25. And there's your answer. Can't reduce 5/7. It's not improper. You're done. Okay, so you can borrow. Let's see if the next one is the same. No, it's not. I want to see if we have any more where we can borrow. It doesn't look like it. So I'm going to come up with another practice for you, and you can always do a similar with this. All right, let's say I had 9 minus 2 4/5. Okay. I have nothing here to subtract from the 4/5. So I'm going to borrow here. And the 1 that I'm borrowing, I'm going to add it over here. I'm going to take the 1 that's being borrowed and put it over here. And I'm going to write it as 5/5. So it matches. So then I can take 5 minus 4. They have a common denominator. And you get 1/5. 8 minus 2 is 6. 6 1/5. All right, so that's kind of how you have to borrow. And again, just hit similar question if you feel like you need more practice. Okay, let's look at number 30 on your homework. I think that just goes to 36, so we're getting there. 9 1/3 x minus 2 1/3 x. Since they both have x's, they're similar, so we can go ahead and subtract these numbers in front. You don't have to write the x's here, but they both have to have an x in order for you to subtract them. They need to be like terms. Wow, 1/3 minus 1/3 is nothing. 9 minus 2 is 7. X. Don't forget the X on your answer, or MyMathLab won't accept it. All right, let's look at number 31. So we're almost finished here. These are some story problems. There will be some applications for your adding or your subtracting of your mixed numbers. So here we've got Casey's beagle is 14 1/4 inches from shoulder to floor. And her basset hound is 13 7/8 inches from shoulder to floor. How much shorter is her basset hound? So the basset hound is shorter by how much? So you'll subtract these. So to find out how much shorter or how much longer something would be or taller, then you would be subtracting. So here we kind of get it set up and give you some ideas on solving it. You're going to take the 14 1/4. Is that showing up there? Yes. And you're going to subtract. Notice that the 14 is larger, so I'm putting it on the top here. I'm going to subtract those. And you'll need to get a common denominator. 4 and 8 both go into 8. So 1 times 1 times 2 times 2. Okay, so I multiplied by 1, multiplied by 1, multiplied by 2, multiplied by 2. So I've got 14 2/8 now, rather than 1/4. Change the 1/4 to 2/8. And I have 13 7/8. Wow, it looks like on this one, in order to subtract these, I'm going to have to borrow because you cannot take 2 minus 7. They're both 8s, which is awesome, but you can't take 2 minus 7. So I'm going to borrow from the 14 and make it 13. So far, so good. And I'm going to add that 1 that I just borrowed to this fraction. And I'm going to add 8/8. I'm going to write the 1 as an 8/8 because I want the denominators to match, which gives me 13, and that'll be 10/8. So 2/8 plus 8/8 is 10/8. So rather than the 14, I have 13. Okay, the 1 is now embedded here. I've got my 1 is embedded. I added it as 8/8 minus 13 7/8. I just keep copying it over because otherwise there's too many numbers. It looks too confusing. Got a common denominator, borrowed. Now I'm ready to subtract. I get 3/8 here. 10 minus 7 is 3. 13 minus 13 is 0. So it looks like they're a 3/8 inch difference in their heights. Okay, it's kind of a little application problem there. That's great. Let's look at this one, maybe at least get it set up. When cutting wood with a saw, ooh, I'm so sorry, that's a little crooked. When cutting wood with a saw, a carpenter must take into account the thickness of the saw blade. Suppose that from a piece of wood 36 inches long, a carpenter cuts a 13 3/4 inch length with a saw blade that is 1/8 inch thick. How long is the piece that remains? Okay, so we're starting out with 36, and we're going to cut this plus the blade width. So it looks to me as if we're going to have to add what we're going to cut off plus the width of the blade. So this is how much is going to be cut off, and then subtract it from the 36. Let's try that. So we've got 36. Well, no, let's go ahead and add these first. How much will we be cutting off? Okay, well, we're going to cut off 13 3/4 plus that width of the blade. Common denominator, probably 8 would be the easiest. You know, if you ever do like 24 something, you're just going to have to reduce your answer more, you know, unless you get the least common denominator. You multiply by 1, multiply by 1, multiply by 2, multiply by 2. Okay. So here we're going to add the total amount that we want that's going to be cut from that board. Looks like we're going to have 7/8, and 13 plus 0 is 13. So 13 and 7/8 is what's going to be cut. What's left? Well, we're going to take our 36 and we're going to subtract 13 and 7/8 from the board to see what's left. What remains? Well, let's go 36 minus 13 and 7/8. Okay, I put the 36 on top there because it's larger. So this is the total amount that's been cut off. Now we're going to subtract it to see what remains. So we need to borrow because we can't take nothing and subtract 7/8. And I'm going to represent that 1 that I'm borrowing as 8/8. I always match the denominator. It'll save a lot of steps for you. Okay, so here, let's see, which one is it? This one's 32. Okay, when I subtract these, I get, because they have a common denominator, so 8 minus 7 is 1. We borrowed, so now we have 35 minus 13. So 22 1/8 inch is what's left. So I added to figure out the total I'm going to cut off, and then I subtracted that to see what remained. We had to get a common denominator before I could add, and then before I could subtract, I had to borrow. So you get 22 1/8. Okay, great. Let's look at maybe another one here. Let's see. Consider 2 pieces of tubing, 1/2 inch and 3/4 inch, 2 washers, 1/16 inch each, and a nut 3/16 inch each. Whoops, let me skip that over. So we've got our tubing, 1/2 and 3/4. We have 2 washers, okay, 1/16 each, and we have a nut that's 3/16 inch. All right, the smallest length of a bolt that will pass through all 3 of these is what? So what we want a bolt that's going to pass through all of these. What would the length of that bolt have to be? Well, it looks like we're going to have to add all of these up to determine the length of the bolt that will pass through those. So we're going to take 1/2 plus 3/4 plus 1/16 plus 3/16. We're going to add these up. Now notice I'm leaving them side by side. I don't have mixed numbers, so I'm not putting them, I'm not stacking them, I'm leaving them in a row. Okay, we need to get a common denominator before we can add these together. Now you could add the 16ths together if you wanted to. Because these 2 have a common denominator, you could add those 2. So let's go ahead and do that. 1/16 plus 3/16 is 4/16. Well, this can be reduced, which may help us out quite a bit. 1/2 plus 3/4 plus 4 goes into here once. 4 goes into here 4 times. So I divided both of those by 4 to reduce it to 1/4. Well, what we can do, instead of getting a common denominator with all 3 of those, these two have a common denominator. So I can add those two. 1/2 plus 3/4 plus 1/4 is 4/4. Well, 4/4 is 1. So 1/2 plus 1 is 1.5. Inches. Oh, I forgot. Is it inches? It's inches. Okay, a whole number plus a fraction is just like 1.5, or 2 and 3. This 2 plus 3/4 would be 2 3/4 inches. All right, just the adding. So there, 1.5 inches. Now my math lab, I'm not sure if they wanted your answer as a mixed numeral. Yes, they do. They want it as a mixed numeral for 33. Oh, wait a minute. They have, yeah. All right. So here, all right. What happened here is that that answer didn't seem right to me. Well, there are 2 washers if you go back and read, and I only added in 1 washer. I am missing a washer because we have 2 washers at 1/16. So I'm missing this right here. So what I can do is I can add in my 16th here. I am missing 1. All right, so we should have had plus 1/16, which would have made this 3, 4, 5/16. Let's go ahead and go back. Sorry about that. Because when I add these 16ths together, I have a 5/16. So we'll look there. I knew, let me find a blank sheet of paper to cover that up with. Here we go. All right, well, it happens. So 1/2 plus 3/4 plus 1/16 plus 3/16 plus, here's our other washer that I forgot, sorry. But I have these 3 of these with a denominator of 16. So I'm going to add their numerators. 1 plus 3 plus 1 gives me 5/16. So now here, it's not quite as easy because I ended up with a 4th here. I'm going to have to change these 3 to a denominator of 16 so I can add the numerators together. So I'm going to have 16, 16, 16. To go from here to here, I'm going to multiply by 8. 8 over 8. Okay, that'll give me the 16 and the 8. This is a good review. To go from 4 to 16, I'm going to multiply by 4. So I multiply by 4 over 4. That gives me 12/16. Then I'm going to multiply to go from 16 to 16, just 1. So I will add the numerators together. So I've come up with 25/16. Well, they want a mixed numeral, so we'll change our 25/16 into a mixed numeral. So 16 into 25 goes once. So it looks like we're going to have a bolt size of 1 9/16 inches. Because they wanted a mixed numeral. They didn't want the 25/16, they wanted the 1 9/16. So that's how you would do that. So again, sorry, I forgot the 1/16 here. They had 2 of those, but you do add the 16ths, common denominator, add the numerators, and then you're done. But that, it wasn't a total loss. It was kind of nice to see, how to, reduce and then add. Okay. All right. So, all right. Well, anyways, last thing, and that deals with 34, 35, and 36. These are very similar to the subtractions we've done before, except here I've got 2 2/5. I have 2 minus 2 2/5. This is larger. So what happens is that it's plus and negative. Your answer is going to be negative. You have more negatives than you do positives. So when you do write these, I would put the larger one on top. Okay, and that would be this one. And I just know when I add these together, which I actually have to subtract because the signs are opposite, all right, that your answer is going to be negative. So in other words, 2 of these positives are going to take away these 2 negatives. So it's going to leave you with 2/5 when you subtract those, but it's going to be a negative 2/5 when you subtract them. So we're dealing with integers now. So we just kind of have to reason through it. So again, we're subtracting because the signs are opposite here. And I know my answer will be negative. I have more negatives. So I put the larger one on top here, and I subtract it. 2/5 minus 0 is 2/5. 2 minus 2 is 0, and I know my answer is negative. All right, so let's try another one of those. Let's try 35. Okay, 35. Here I know that this is going to be 5 1/5 plus a negative 9 9/10. 9 is larger, so I know that I have more negatives than I do positives. How many more negatives do I have? Well, the fraction part, I've got 4/5 more of the fraction, 8/5 more. Where did I get 9/5? Oh, okay. It's 9/10. Why I got the fifths, I don't know. I'm like, oh my goodness, that does not work out. All right, so here we're going to change it to a denominator of 10. So we have multiply by 2, multiply by 2, multiply by 1. So I have a negative 9 9/10 and a positive 5 2/10. All right, so again, I had to get a common denominator. I rewrote it wrong to begin with, but this should have been 9/10 and 1/5. A common denominator of 10, they both go into 10. So here multiply by 2, multiply by 2, multiply by 1, multiply by 1. So we have a minus 9 and 9/10, 5 and 2/10. So that when I combine these two, these are negatives and these are positives, I'll have 7/10 negatives left. And I'll have 4 negatives here. So your answer is a -4 and 7/10. So you're subtracting. Your answer will be negative since you have more negatives, but go ahead and put this one in on top and this one underneath. Okay, put the larger one on top and that one underneath. Okay, let's try another one. And that's our last one, number 36. Number 36 here. I have a -4 and 3/7 and a -3 and 2/7. So both of these are negative. So I will put the larger one first on top. They're both negatives, which means I will be adding them together. So I'll have 5/7. I don't have to get a common denominator. Okay. How many negatives do you have? Well, looks like we have 5/7 negatives. And then when you add these, you get 7. So you have a -7 and 5/7. Now, these don't occur very often, but I just wanted to touch on them and let you know that they're available. Okay, all righty, that covers it. So this will finish those 3 sections. We have 2 more to go, but I hope by going through each of these homework problems that helped. All right, okay. Well, let me know if you have any questions. Talk to you later. Bye-bye.